Alright, we're looking at the segments of a chord. Segments of a chord. So first, what we have here is a circle. So the segments of a chord theorem, 1, 2. We need to have 2 of those points. Let me just turn off the light real quick. So we have to have 2 of those chords, A, B, C, D. Alright, we have A, B, C, D. Just to make it easier, I'm going to represent these as each length is a lowercase letter. A, B, C, D. So A represents this length. Then you have B, which represents this length. Then you have C, which represents that length. And then you have D, which represents that length. Alright. So, by the theorem, we have the following. We have A times C is equal to D times B. So what that's saying is A is going to multiply by C, and then we'll have D will multiply by B. Alright, so that's the formula for it. Let's do an example, and we'll move on forward. Let's just assume that's the center. Oh, it isn't. No, it doesn't even matter if it's the center. X. That's just where they collide. X plus 2. X plus 1. Then we have X plus 4. So again, we can just show it that you're going to multiply these by each other, and you're going to multiply these by each other. So what we have here is first X plus 2 is right there. It'll be X plus 2 multiplied by X plus 1 is equal to X times X plus 4. So here you do have to distribute. So it will be like this. X times X, X squared plus X plus 2X plus 2 equals X squared plus 4X. Simplify it, you get X squared plus 3X plus 2 equals X squared plus 4X. Alright, lucky for us, we don't have to do much factoring from here. I notice they both share an X plus 2, so we can subtract it by, it doesn't really matter. We subtract those, they would cancel. So now we're left with 3X plus 2 equals 4X. From here, I'm going to subtract the 3X. We get 2 is equal to X. Alright, and that's our answer. You can plug it in and multiply the length of this chord by this chord, and they'll be equal to each other. Alright, and that's segments of a chord.